we are going to see what elements of the periodic table actually form what we call the ionic bonds, and what are the characteristics of compounds that are having ionic bonding, what we basically call ionic compounds. What characteristics do they possess in terms of whether melting point, boiling point, electricity, conductivity of electricity, and things like that. Okay, so let's start. When we talk about ionic bond, there should be a metal cation, and then there should also be a non-metal. Okay, so that's the basic thing to start with. So there should be a metal and then a non-metal. So what happens is that an electron, where you have electrons being transferred from the metal to the non-metal. So remember, metals have higher tendency of losing electrons, okay, such that they become cations. And then the non-metals are good at accepting the electrons. So in an ionic bond, you have electrons being transferred from the metal to the non-metal. Usually, we use the example of sodium chloride in illustrating ionic bonds. So you have sodium chloride. That's sodium chloride. So electrons, one electron in this case, is moved from sodium chloride, from sodium to the chlorine. We use here. So why does that happen? First of all, you need to know the electronic configuration of the atoms that are involved in an ionic bond. So for sodium, you have 11 electrons and 1 electron in the outermost shell. You can see with this electronic configuration. So that means that for sodium to attain the noble gas configuration, it should have 8 that is to obeying the octet rule. So it easily loses the 1 electron to have that stable configuration. So it loses it to chlorine. And then chlorine, remember here, is having 7 electrons in the outermost shell. So when it gains that 1 electron, it becomes 8. So that means that actually forms a stable compound in there by 1 metal, which is sodium, donating or giving out 1 electron and then the other accepting. That means you have an ionic bond in there. Okay, so that ionic bond is characterized by the electrostatic attraction between the ions that you are basically having. Just make sure. Pen. Electrostatic attraction. Is it not working? Okay, the electrostatic attraction that you have between the 2 ions, that is the sodium ion and the chloride ion. Okay, remember, metals form positively charged ions that we call cations, and then non-metals form negatively charged ions that we call anions. So the attraction between the positive and the negatively charged ions results into that ionic bond that we are talking about. Okay, so by losing 1 electron, sodium attains the stable electronic configuration similar to that of neon, and then the addition of 1 electron to chlorine atom makes it attain a stable configuration to and that means that the electrostatic attraction, the positive charges, the positive and negative attractions constitute what we call electrovalent bond of the ionic bond between sodium and chloride ions in sodium chloride. So we have different ionic compounds or different compounds that have ionic bonds. We have started by talking about sodium chloride, but we also have magnesium chloride, calcium oxide, magnesium oxide, and also magnesium lithium oxide. Okay? So what is unique about this ionic compound is that, of course, they exist or consist of ions, the cations and anions. So they don't exist as molecular compounds or molecules, basically. So they are electrolytes. That means that when dissolved in water or when fused, they can conduct electricity because they actually decompose into ions that can migrate to the electrodes. And then you have high melting points. That means that these ionic bonds are actually very strong. High melting points, also high boiling points. They're basically solids with high melting point and boiling points. Okay? And then we move to the fact that they are actually insoluble in organic solvents, but very soluble in water. So the structure, if for example sodium chloride or basically ionic compounds, is that they form a large structure that we call the lattice structure or the lattice formation. With this, you have the cations, the positively charged ions, and the anions, the negatively charged ions, arranged in a structure like what you see here. This is a kind of depicting a 3D structure of the lattice, very giant ionic structure where you have electrostatic attractions in there. Okay, so you have each sodium ion actually being surrounded by 6 chlorine ions, and also the same thing happens to chlorine ions. Is it chlorine ions to chloride ions? Okay. Thank you for listening to this presentation, where we have basically noticed that if you have cations and anions, you will have electrostatic attraction between them, and this results into what we call electrovalent bonds, or what you call ionic bonds. These bonds are usually stronger, and they give compounds very high melting and boiling points, but can actually dissociate, especially if dissolved in or in aqueous solutions, and therefore they can exist as ions, and because of that they can conduct electricity. They form very huge structures that we call the lattice structures. Thank you.